Hello everybody. In this video we are going to start our conversation about all the different transformations that we can apply to a quadratic parent function. So if you're unfamiliar with transformations, that is going to be reflections, vertical compressions and stretches, vertical and horizontal translation. Now, when we do all of these transformations, we're going to do them and compare them to the parent function. Now, before we can actually look at all the different quadratic transformations and talk about the quadratic parent function, I do want to take a moment to talk about all the function families that exist in Algebra 1 and their parent function for each one of those. So let's take a moment to look at linear, exponential, and quadratic parent functions. So I want to start off with what is a parent function. Each function family has a parent function, which is considered the most basic function in its family. So it's going to be the equation before we add any extra numbers. And if you look at the linear function, the parent function equation is just x. So by graphing just x, we have this line that starts at 1, 1, 2, 2, 3, 3, 4, 4, and it goes in the opposite direction as negative 1, negative 1. So the x's and the y's are exactly the same. So a couple things to note about this linear parent function. Number one, it has positive slope because this line is going in an upward direction. The slope is 1. Rise 1 and run 1. Okay, and then our y-intercept is 0, 0. So notice that this graph does cross and go through the origin. Now, one of the things that I'm going to point out about these notes is a lot of these graphs are already going to be on my coordinate plane because we spend a lot of time actually creating these graphs, that it will speed up our video and it'll make our conversations more productive if these graphs are already on there. So if you don't already have these graphs, I encourage you to pause the video and graph all of the functions so that way you can follow along with the conversation. Okay. So the next thing we're going to talk about is this exponential parent function. So if you look right here, this is the equation that we're using for this particular parent function. We're using numbers 1 and 2, and our x is raised as an exponent. Now for this one, our exponential is going to show growth because it's increasing from left to right. I also want to point out that we have a horizontal asymptote. So if you forgot what that is, it is a horizontal line that your graph will never cross or touch. We also use it as a guide. So notice that when I create my points, I'm also using this horizontal asymptote to kind of glide the rest of my graph because it's going to get closer and closer to that line, but it will never cross or touch it. And as you can tell, we do have a y-intercept, and the y-intercept for this exponential function is going to be at 0, 1. Okay, so this is the exponential function. So let's go ahead and move over to our quadratic function, which is this one right here. And notice that if you compare it to the linear function, it has an x. And if you look at the quadratic parent function, this is x raised to the second power. So the only thing that makes these different is that this one is raised to the second power. So by adding the 2, it goes from being a straight line to a curve. Okay, so make sure that anything that's going to be a quadratic function or that belongs to this family right here, the highest exponent is going to be a 2. Once we change it to different numbers, then your graph will start to look different and it will belong to a different function family. But since we're just talking about quadratics, then the highest exponent is going to be a 2. So let's talk about this graph. This is a graph that opens up because there is an understood positive 1 here. We also can see that our vertex, which is the point that's in the middle of our quadratic or our parabola, it's either the highest or the lowest point on this graph. Our vertex goes through 0, 0. Okay, so this is what we're going to be talking about. This is what we're going to compare to every single one of our transformations in Algebra 1. So you need to become familiar with these points because we should and we're going to add these to every single graph to constantly compare back to the parent function, no matter what transformation we do. Now, before I move on to the quadratic standard form equation and the quadratic vertex form equation, I do want to remind you how to create these graphs. So I'm going to show you how to do the quadratic function. I do want to remind you that I'm using a TI Inspire. So if you're also using a TI Inspire, you can follow these steps. So I'm going to go ahead and set this right here. I'm going to start off at the home screen. I'm going to hit number 1 for a new document. I'm going to hit number 2 to add a graph. And I'm going to add my equation right there for F1, which in this case is x to the 2nd power. I'm going to hit enter, and this is what my graph looks like. Notice it's very similar to what we have here. But for me, when you're graphing something for me, I'm going to ask you to use exact points, and the only way you're going to get exact points if you use the table. So for this one, I'm going to ask you to hit the control button and hit T. And notice that it does bring up this menu. My suggestion, if you have any questions about graphing these, is that you want to always look at your x-axis and start with the smallest number. So notice that there's a -5 here that we can't see, but we know it's there. So anytime I'm going to try to figure out how I'm going to start this graph, I'm going to start with whatever the smallest x value is and then work my way through. Notice 25 is too big, so I'm going to skip it. Next comes -4. Notice 16 is too big, so I'm going to skip it. And then you'll see that the next number is -3, +9. And so that's this point right here. And then if I continue, -2, +4, -1, 1, 0, 0. I'm going to keep on going. 1, 1, 2, 4, and 3, 9. Once I go past the 3, I'm going to go into numbers that I can't graph. So that's just a quick reminder on how to use your calculator to generate these graphs or generate a table so you can create your own graph. So before I let you go, we're going to go ahead and look at 2 forms that have to do the quadratic formula. So for quadratic standard form, this is what we use when we factor. Notice that we always have 3 numbers, our A value, our B value, and our C value. Now, when we're factoring, we use this, and when we begin to use our quadratic formula, we're going to need this as well. But for what we're doing and for transformations, we're going to use this form right here. So we're changing it from here to here. It looks a little bit different, but we still have an A, which is in the front. We have this -h, which is inside the parentheses. And remember, for a quadratic function, we have to have it raised to the 2nd power. So please don't forget that 2 when you're typing things in. And then lastly, we have this K at the end. Our A, our H, and our K do different things to our graph. And that's what we're going to look at individually. So I hope that this quick explanation on parent functions has helped understand a little bit more about what a parent function is, because that's what we're going to use to compare and identify transformations. I'm going to pause right here. I'll see you in the next video.